All right, welcome back. We're going to go ahead and do 2.4, which is talk about the binomial theorem. Before we talk about the binomial theorem, let me explain why we're even interested. So, if I asked you to expand x plus 3 to the 10th power, a lot of you would probably have to write it out, x plus 3 times x plus 3 times x plus 3, 10 times, and then go ahead and distribute everything. That would take forever. The binomial theorem is actually a shortcut method that helps you go ahead and expand it term by term without having to go through that process. In order to use the binomial theorem, you do have to be able to know how to find a combination. You don't really have to know what a combination is. You just need to know the formula. So combinations are written either like this, n choose r, or n choose r this way. But the formula, regardless of how it's written, is n factorial over r factorial times n minus r factorial. Just as a note, a factorial just means that you're going to multiply that number by all of the whole numbers after it all the way down to 1. So 5 factorial would be 5 times 4 times 3 times 2 times 1. 10 factorial would be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3, 2 times 2 times 1, and so on. Your calculator has the ability to do factorials. If you look at the PRB, it also usually has the ability to just do the n choose r. Look for a PRB, that stands for probability button, or the math button if you have a graphing calculator. If you can't find it, let me know. Okay. But this is how the binomial theorem works. We've got a plus b raised to the n power. So you'd start out n choose 0. And then you take your a term and raise it to the nth power, and then take your b term and raise it to the 0 power. Then we go and choose 1, and we do a raised to the n minus 1, so we take off an exponent, and then b to the first. Then we do n choose 2, and then a would go down to the n to the minus 2 power, and then b would now be to the second power. This would continue until you get to n choose n, and then a would be the 0 and b would be to the nth power. There is a little shorthand way of writing this called summation notation, where you'd write k equals 0 at the bottom, n at the top, and you do n choose k. What this k at the bottom is saying, we're going to start with 0, and then you're going to plug in 1, then 2, then 3, then 4, all the way until we get to the whatever n is. And then likewise, we'd have a raised to the n minus k and b raised to the k. And this formula defines every single one of these terms in between without having to write every single one. Okay, so let's go ahead and learn how to actually use this on a specific problem. So here's our example. We've got x minus 4 to the third. So this is our a, this is our b, and that's our n. Because remember, it's n to the n power. So let's work our magic. So this is the way we would do it. Now, just as a note, I wrote these horizontally. I'm going to write each individual term and then write the successive term just right underneath, just to keep my work more simple for me. You don't have to do it this way. So our n is 3, so we're going to start with 3 choose 0. And then the next one would be 3 choose 1, 3 choose 2, and 3 choose 3. Our a is x, so all these will have x's on them. And we'll start with x to the third, x to the second, x to the first, x to the 0. Our b is negative 4. And we'll start with 0 for the first one, for the first exponent, then 1, then 2, then 3. And then we just have to simplify. So 3 choose 0 is 1. Oops, thought I had the highlighter. Negative 4 to the 0 is also 1, and then we have x cubed. I have the other term at the end. So that's this part right here. 3 choose 1 is 3. Negative 4 to the first is negative 4, and we have x squared. So this is negative 12x squared. The first term is going to just be x cubed. 3 choose 2 is 3 if you use the formula or if you use the calculator shortcut. Negative 4 squared is 16. And then we've got x. So that's 48x. 3 choose 3 is 1. X to the 0 is 1. And negative 4 to the third is negative 64. So it's just negative 64. So your answer is x cubed minus 12x squared plus 48x minus 64.